Okay, are you getting my voice?
No, sir.
So till whole period you are just listening and no one has accounted that sir voice is not coming or something. The thing is, I have recorded this from my this phone. I'm unable to transfer to laptops. That's why. Uh, okay. So what I will do is, mm, I could shift to the another segment, another video where I would be explaining. Okay, the theory part would be considered on later part. Now tell me whether this is coming or not. You're
Coming,
getting.
sir.
Okay, this is the experiment. This is the actual setup where you could see. Okay, it has been clearly written active and reactive control of an alternator, where the infinite bus is your segment that is being consider from your grid segment, and at the right hand side it is your alternator, and they have used a three lamp method. Okay, uh, in three lamp method also we have a different methodology to adopt. Okay, they have used one dark and two bright method. What that sequence sorry that particular sequence was shown how this bulb connection is being done. Okay, to measure which your the top one. Okay, the in out of three, the top one, that is your RR, and the below two are connected in your uh, phases like YB and your B to B part. Okay, in this particular segment, so you could see all the segment there, and the lower part. Okay, if you could see in lower part over here, it is written a DC bus. Okay, now that DC bus is being taken to power up your generator, sorry, your prime mover. Okay, your DC motor that is we have using. Okay, so this particular knob is being given to increase the speed, and another for alternator we have only excitation field. Okay, to provide the excitation. Now whenever you are running, okay, or if you could consider that one DC motor is being coupled with your alternator. Okay, so what will happen if you are rotating that DC prime mover or DC motor at a rated speed, that is 1500 rpm. Okay, so that particular segment, that is your alternator, would also be rotating at 1500 rpm. Okay, but it will not start generating until and unless you are giving the excitation. Okay, the field excitation is provided to your alternator, there would be no generation. Okay, now when you are running, okay, means both are running at rated speed, okay, and the field excitations are being provided, okay, there is one terminology that you will come across or you have come across, okay, that is your residue voltage or residue current, okay. So that would be seen whenever it is being rotated. So until unless you provide the field excitation to your alternator, it will not start generating. So now the entire process would be how to synchronize what segment you have to see and what segment you have to consider. Okay, let's move ahead.
सर वॉइस नहीं आ रहा है.
Okay, so I would be telling you parallelly. Okay, I'm muting this and I will be telling whatever is being done. Okay, so now what I'm doing is I'm making your DC motor to run at 1500 RPM. That is what we have. Okay, we have to fix. So I'm just adjusting the knob to it should be at 15. You have to rotate very patiently because you will not have to increase at a certain node. And until unless you provide, okay, your excitation, so you could see over here only your VLL, that is your uh, line voltage, that would be provided at this particular segment, but the alternator part there is no rating. Now you could see now at presently your 51 52, that is your residue voltage, okay, that was I was talking now. Yeah, and there is a sequence, okay, of your bulb. From the sequence of your bulb also you could get accounted that in which means which position what you have to do, either you have to increase or decrease the excitation part, okay, based on the behavior of the your bulb rotation, okay. So I think so I have missed one particular part. Okay, I will show you. I will have one another because we have two particular periods. So in that particular period, I will show you how to synchronize or we could check the phase connections. Okay, how we could check the phase connections. Okay, so I will go a little bit back and I will start. Okay, now, so what I have done, I have fixed it this at 1500 RPM. Okay, your DC motor, or you could consider a prime mover, is rotating at 1500 RPM. Now you could check the all the ratings provided. Okay, your motor voltage is 205. Okay, your motor current is 1.18. Your speed over there you could see, and your excitation is almost zero. Okay, W and W2 boxes. Yeah, please. Someone is saying something.
Sir, some students are waiting, sir, to join.
Okay. This is issue in this particular. I don't have, when I am sharing that, I don't have access to this. Hold on, okay. Me have access to this. Okay. So after uh, making this prime mover rated speed at 1500 RPM, okay. So now our the second main purpose is to hold. Yeah. Okay. So this part has been done. Now you could see over there, okay, we'll revise this. Okay, now you could see in the alternator bus segment, you have some voltage and frequency is 0 till date, okay, and you're getting your some ampere ratings over here, right? Now these are the residue current and residue voltage you will get because alternator is also rotating at that particular speed where it should get start generating, but we haven't provided the excitation yet, so there would be not any applicable thing. Okay, they will not get a generation, but because of rotation you will get some residue voltage and residue current. Now next is we are rotating, we'll start rotating your alternator, right? Means we are providing the excitation. Now whenever you are start, you will be providing your excitation. Okay, so you could assume means there would be a pressure on your uh, prime mover, okay, which will tend to decrease the speed. Okay, so you have to maintain that particular speed also. Okay, the speed should be also maintained. Okay, so what I am doing, I am controlling both the unit and I have to maintain that particular segment. Now after giving providing you the excitation, you could see your frequency has also been okay, you could see frequency is also there, voltage is also been generated. Okay, now what you have to do is you have to match your voltage and frequency, and you have to parallelly see this particular segment. Okay, this particular segment where at the straight horizontal unit there is a null position. Okay, whenever that uh, knob will come at null position, that is at the 0 point. Okay, at that very instant you have to press this synchronize button. Okay, at that very instant. Okay, so let's see, will not switch on that. That's okay. Now at this particular instant it has been synchronized. Okay, you could see your top part. Okay, top bulb is your dark position and two are the your in is in a it's glowing. Okay, now you could check the rated voltage and all. Okay, it's 384 and 50 0.01 over here also 384 and 50 02. Okay, it's almost same. Okay, so this is now been synchronized. Just a minute, I messed up. Okay, now so on this particular segment, okay, even if I have taken a close view, yeah, right, yeah. Okay, this is a phase sequence. I will also show you how this phase sequence meter is used and how it is being operated. Okay, to know the phase sequence of any particular bus or the alternator segment. Okay, what we have seen, how you have to check out. Now, so what I was saying, this at this particular unit, okay, you could see this is your actual null position. Okay, we don't have your armature and field different segment. Okay, in few of the experiment what we have done in our BTech time, okay, we don't have this particular segment, we have different units. Okay, so we used to have rheostat, okay, that was connected to the armature part of a motor and your field part of your motor, and parallelly with field and armature part of your alternator segment. Okay, now, so this is, you have to declare that this is your null position at which particular point you have fix or synchronize this segment. Okay, in if you have any different segment, okay, or any different particular machines would be there instead of this entire pre-bond setup. Okay, what you will do is you will have your armature, okay, extra rheostat, okay, that is your resistance, variable resistance would be connected across your armature. Okay, that would be increase or decrease for this particular purpose. And you will also have your alternator, extra alternator, sorry, extra rheostat that would be connected to the field, okay, excitation field, that would be rotating. Okay, that particular segment would be increase or decrease for finding your, or to control the reactive part. Okay, reactive power. But as we do not have, okay, uh, we do not have presently, we do not have any particular uh, segment. Okay, only one setup is been provided. So what we'll use same knob to control your active power. Okay, so what, by seeing this is your initial position. Okay, at now, at this particular segment, if you rotate any of the U2 unit, either your motor part, okay, or your excitation part, okay, there would be no changes. Okay, there, if you rotate that, there would be no changes in your this segment. Okay, there would be no changes in this. That's why I was accounting that this was the initial position. Whenever we will control your active power. Okay, so we have to come, or we have to adjust again back to the initial position of the synchronization. This is this particular unit. Okay, I think so. I have, okay. Now, what I was telling that whenever you move, okay, you will be rotating this particular prime mover. As these both parts are synchronized, okay, there would be no effect. Okay, there would be no increase in your speed, and there would be no changes in your uh, ratings. Okay, but though it is in a synchronized position and we are still providing more and more resistance to the armature of your prime mover, okay, it will not rotate, but it will tend to rotate. Now, this will increase, or this would leave the current. Okay, your voltage would be same. Okay, on rotating this, your voltage would be same at both the end. As this is floating on a bus bar, what will be changing, your current would be changing, and we know that power is what, V into I. Okay, with, if V is your constant segment, then what will be rotating, means what will be increasing or decreasing, that is your current. Okay, so we'll monitor the changes in the current of that segment, where your frequency and your voltage would be kept constant. Okay, only the current part would be increase and decrease whenever we are giving more and more the resistant part to your prime mover, or we are providing more and more of your excitation to the alternator. Okay, this case would be very constant at that particular segment. Okay. see the current of that particular say motor of is increasing. Okay, that will also tend to increase your current in alternator and even to the infinite bus bar. But whereas your voltage and your frequency would be constant for both the segment. Okay. Okay, if you could see now it is 1.4. If we go back, see it's from 0.5 on increasing, it's get increased. Whereas your there would be no effect on voltage of and current of this particular segment. Over here also we'll see there would be no effect. Right? See, there is no effect. 379, 49.99. But on increasing, we would be that particular segment is increased. Okay. Now, so this is being controlled. Okay, this is how we control the active power. Okay, whenever it is been synchronized, we have will give more and more resistance to your armature of your prime mover, that it will be at the same speed. Okay, the speed would be not changing, but your more if we require more active power to uh, boost into any particular synchronized bus bar, this is how we control this. Okay, now we are setting back it to the normal position what it was earlier. Now what we'll do, we'll control the reactive power. Now for controlling the reactive power, what we have to control, we have to control the field of your alternator. Now whenever we will be increasing that, okay, this reactive power would be in the lead segment, and whenever we would be reducing this alternator segment, that would be in lagging reactive power. Okay, so this is how we control. Okay, this terminal is done, and you could see over there. Now based on this, we'll have a few uh, calculation how W1 and W2 is being calculated. We could, based on that, you could calculate your active and reactive power based on the readings from W1 and W2. Okay. Now we are increasing your field excitation. We are providing more and more excitation. There would be no changes in that, but the current part would be changing as we have change in active part. Okay, so for leading active reactive power, you have to increase this. You have to provide more and more that, and for lagging part, you have to decrease from the initial state of the synchronization. Whenever you have to decrease more, the reactive power is more, okay, in a system. Okay, you have to reduce. So what you will do, you will reduce this excitation part. So this is how it will be controlled. Okay, as this was the unit. Okay, we'll try to cover up. I will show you the live. This was the recording part. I would try to show you in recording part. Okay, in the second half. Okay, there is a lot of issue in our college for power. Okay, so that's why I was unable to get you down in lab. But in second half, I would be trying to get it. Okay, I will provide you a link to kindly join in that particular segment, and we'll see everything in live manner. Okay, I will try to get it done in the lab segment itself. Okay, where you will be understanding uh, more of it. Okay, we'll see that and we will understand that particular segment more easily. Okay, where I would also come you across with this phase sequence meter, how we are using that, and also one of the entire kit is there. Okay, where we could easily see the your phase sequence. Okay, randomly three phases are being given. You are not being notified that which of three is your R, Y, and B. So based on this, you could assume that, okay, or based on, or using this synchronous phase synchronous method, or based on two bulb inductor or conductor method. Two methods are also there. Based on that, you could guess out, or you could see that this is your phase. Okay, this is in phase RYB, or this is in out of phase. Okay, there is two methodology. Okay, I will be telling that now. The remaining few second was uh, whenever you are doing any particular experiment. Okay, the process is you do not kindly switch off the entire segment. You have to go the procedure. Okay, the what procedure you have followed, you have to come back the same procedure. You have to come return on the same path. Whenever you have chosen one path, you have to return in the same path. That's what in the few of the this minute was I was telling, that you have to follow the same sequence. Okay, so I'm ending this. I would try around 3 or 3:30 whenever the power would be available, and I would be providing you, or from the same link you could join, where I would be telling, I will be showing you the another experiment as well. And if you have any particular doubt, you can ask me right now, or you could uh, come to that particular segment in the second half, and we will be discussing on that particular time. Okay.